Alrighty, welcome everyone to week 4, day 1. We're going to learn a little bit about recursion. Let's go ahead and dive into it. I have here the problem that we are going to have to solve today, and in order to solve it, we're going to have to take a look at what we're required here. It says sum of integers from 1 to input integer. Okay, so we're given an input of 5, and the expected output should be 15. So if the input is 5, what we are looking for is a function that will add 1 plus 2 plus 3 plus 4 plus 5. So you see that there is a repetition in the way that this function calls a sum of what is given plus what it is. So the first one would be it would count, and they would have to stop it count. So it's kind of like a loop in a sense. It is a for loop in a sense, but you're using the function's name and call for itself in order to do it. So in order to explain this, let me go ahead and bring up another code page here so I can show you what a recursive function looks like. So let me go ahead and show you one here. Give me a second to pull this up. Okay, here we are. So here we have a function. We called it myfunc. And what this function does is console log hi. And then what it returns is a call to itself. And so let's see what happens if we call this function as we see in line 34. This is an example of a recursive function where the function call calls itself and it's giving it in the return. So let's go ahead and run this. Oh, something happened. What happened here? Anyone have an idea, clue? Yes. It's okay to be wrong. Let me check the chat here. It went on forever, right? Call stack full. This is called stack overflow. So a call stack is when your function is told to do something. Well, let's ask before I give a long explanation. Who can tell me what a call stack is? Function scope. Okay. Can you give me a little bit more description in a couple words? So imagine a stack to be something like this, right? And then whatever thing your function does, so for example, the first thing can do to run function, and maybe your function has a for loop inside, so then it will say, okay, run the for loop, and then it will say maybe inside the for loop there's an if statement, so it'll say if statement. If the if statement passes, then it crosses this out, and then it continues on with the for loop, and then maybe it finishes the for loop, and then it goes back and it says, okay, this is the last thing to do. Now the function, run the function. So that's complete. So the stack it fills up, and then it goes down as the requirements are fulfilled. So a stack overflow is when you just keep stacking up function calls for the stack to do things. And so this is what happens when you call a function of itself. It just keeps telling something to do, and then there's no end to how many times it's told to stop. So here we have infinite numbers of highs until it says, hold on a second, this is going to go on forever. we can't do this anymore. So it says maximum call stack exceeded. Okay, do we understand that? Let me just take a quick poll here. Okay, so now let's move on. I think enough of us understand that if we broke out into groups and needed to figure it out, we could explain it to one another. So let's go ahead and look at the next example here. 1 second. Okay, so let's look here. In this example, I call the same function and I give it an argument in the parameter here. I say I equals 1. And I say if I is greater than or equal to 100, return 0, and then it will stop. So this my func will call itself just as it was before, and now it can do something. It will console log I, so it will console log every iteration of I, and then it will add to itself +1. Okay, so let's see how this will work. Okay. Okay. So what do we get? What does this remind you of? A for loop, right? Because it loops through it loops through a sequence and then it prints them as it until there's an endpoint. So you can use a function call to itself like a for loop, and you can benefit from understanding how that works. So here we have console log I, then the function says, okay, return me I +1. The function call then calls itself, and it just keeps running until this if statement, it goes greater than or equal to 100. Would you not be able to just do a nested for loop? I could do a for loop. Is there a difference in time complexity doing it this way versus a for loop? Now that's a good question. I believe recursion is not always the best or ideal time complexity. Sometimes it is the most simple to understand and sort of write a function this way. But it's good to understand it. I want to give you a more in-depth answer. I don't think we've gone into explaining time and space complexity yet at this point of the dojo. So you will get a thorough explanation of that and as to which functions, will help you there. But for now, we know that we can call a function in the function and return a different value, and it will essentially work as a for loop if we have an if statement there that will stop it. So as you can see, this is something that will help us solve the algo objective there. Okay, one more thing I want to show us here. Do we understand how this works? Let's do a quick poll. Okay, looking good. All right, so let's continue. So you can take the time to look at this and digest this while you're in your group or in your own time. It's always on the recording, but if you need to take a screenshot so you can understand how this works. Play with it, break it, make it Stack Overflow to see how it should work and doesn't work. It's always good to just write the code and See if it works. You have to test it to be familiar with it. All right, so one last thing here. Maybe I can show you one more thing before I break us out into groups. All right. So let me see here.
A Sorry to interrupt, Josh, but before we get started with algos, what would you like to do for exams? I know there's some folks taking today.
Yes, I know. For the exam takers, we're just gonna do the morning algo. Let's just get through it. Um, I figured I could go through and make all the rooms, but it's a little bit too much disorganization, I think, for a little bit. And so let's just do this. The exam will still be there, and we can extend the time in the day that you can take it. I wouldn't mind grading late in the day myself. So cool. All right, so let's take a look at this. Um, all right. So last example. Because let's take a look here at the problem here. Recursively sum given int and every previous positive integer. Okay, so let's look at this example here, 2.5. We are expected to give a 3. Why? Because every number leading up to 2.5 is summed, 1 plus 2. And then here, we are giving a negative 1. So what do we receive when given where negative 1 is the parameter? We have a 0. So return a 0 if it's a negative number. So let's go ahead and solve this. We're going to recursively sum the given int and every previous positive int. I'll go ahead and break us out into groups, and let's get to solve this. Welcome back, everyone. I hope we enjoyed that algo. Now, I saw some groups completed it, and I'd like to have Jacob's group present. Jacob, could you share your screen for us, please? Or Valerie, whoever it was.
Yep. Okay, for our solution, um, we just set a base case for if the number is negative, we return 0. And then for case number 2, if it's a decimal, we just use math.floor to convert it to an integer. And then we set our base case for the recursion. So it's kind of like a while loop in a sense. And then we return 1, and then else we'll just keep using recursion and keep adding the numbers from the back all the way up to 1.
Okay, what do you mean by that exactly? Adding up numbers from the back.
So if it's since it's like 5 right here, we'll just
Yeah.
do 5, and then it will do 5 plus 4, or but then right here it has negative, it has number minus 1, so that's how we know we're adding 5 plus 4,
Okay.
and it'll keep recursion doing recursion until it meets the base case,
Okay.
and it'll return the results.
Okay. All right. So do we see what Jacob's and Valerie's group does there? We have a return which returns the num plus the recursion call of the num minus 1. So whatever given value we have, in the first case, let's do 5, right? Whatever given value we have 5 plus 5 minus 1, which is 4. And then you do that function call again with 4, and you say, you add the number of 5 plus 4, which is 9, to 4 minus 1, which is 3, right? So then you do 5 plus 4, which is 9 plus 3, and then you get 12. And then you do the last numbers from 3 down to 2, and then 1. 2 plus 1 is 15. So you have that recursion call until you can no longer add, which is when you get to 0, right? When you subtract that number and then it's 0, that's when the function call stops. That's when the if statement triggers on line 27. And it says when num is less than 0, then that's actually for negative, sorry. And then on line 29, it says if num is equal to 1, that's when you have finished the recursion of subtracting from the number value given in order to receive the sum of that number's leading up numbers, right? So, okay, do we have any questions about how this works? I'll go into depth about it, either on my screen or on Jacob's here, but great job, Jacob's group. Anyone else have a solution that's similar but not exactly the same they like to present? Okay. Alrighty, well, thank you, Jacob, for sharing. I'll go ahead and share a quick solution because I'd like to just for a moment. All right, so here we have our function recursive sigma. It takes in the value n here, and what we have is a variable called int. Why do we have this variable called int? It's because this method parseInt converts a string to an integer. So if for some reason n is given a value of a string, I mean, we can't work with the string's value because a string is not a number. So we assign to this variable this given string to we convert it to a number. And so then we say, we're going to hold this number value in this variable called int. So that if, for example, our function call receives a string instead of a number, it's going to convert it to a number. So it's just handling that as well as it's also getting rid of decimals. All right, so we convert it to a number, and then what else do? We check. If we're not able to turn it into a number, or if it's not a number, then we return null. So it's checking a condition to see if it's bad data. So this is what this is for. We have to handle those types of cases as well. All right, and so here's the base case. So this is when we stop. If int is less than 1, then we return 0. That's because we have finished the recursion. So this works exactly the same as Jacob's groups does. The only difference is that I'm handling these conditions. I turn it and I check to see if it's not a number, if it's bad data. If I cannot convert it to a number and hold that number into something we can work with recursion, then we handle that with this if statement. Otherwise, we have our base case, and then we have our recursion. Alrighty, everyone. So that pretty much wraps up today's Algo session. Let's go ahead and take a break and then go straight into our day. Let's stop the recording.